All right, welcome back. And we're going to talk about hexadecimal. So, hexadecimal is referred to as base 16. And base 16 will be that there are 16 digits that make it up. The 16 digits are going to be that we start with our normal decimal items. So we'll do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10. So we need to get to an extra 6 in. The way we're going to get the other 6 is we're going to start using letters. There's no, it's any way you want to. You can use capital letters. You can use lowercase. There is no common convention. So I'm going to use capital letters. So I'm going to say it's A, B, C, D, E, and F. Now, hexadecimal, usually this is just shorthanded to hex. A lot of times you will see hex that instead of using like a subscript 16 after a number, you would see it as it's starting with 0x. And this kind of is a key to using hexadecimal. So let's say it's 0x, and then we'll give it a number. Let's say it's 340A. Now we can take this 340A and we can say again that each spot has a weight 16 to the 0, 16 to the 1, 16 to the 2, 16 to the 3. And you can go and you can figure out what this would be in base 10. Now, the key item is when you have an A, so you have A times 16 to the 0, that's the same as saying I have 10 times 16 to the 0. Here, let's change this 4 to an F. Well, when you do this F, you're going to do that as 15 times 16 to the 2. All right, so you got to remember that A through F, this is 10, 11, 12, 13, 14, and 15. Okay. Now, a lot of times when we use hexadecimal, hex is used as shorthand to tell a binary number. It's not often that we're going to use it to say, okay, take this hex and convert it into a decimal. A lot of times we're going to go hex to binary and binary to hex. There's going to be a real usefulness of this. So let's say we had a binary number and we had a very long binary number. Let's say it's 1 0 0 0 1 1 0 1 1 1 0 0 0 0 0 0 0 1 0 0 1 1 0 1. And you have this binary number and you want to tell it to someone else. And you can see that there can be some difficulty in repeating it. So to kind of make things a little bit easier, what we kind of look at is that we say hex is the breakup of a binary number into groups of 4 bits. So if I have a 4-bit number, each of these 4-bit numbers will give me something between 0 and 15. So I would have 0, 0, 0, 0. So this is binary. And let's say, what does that add up to in decimal? That adds up to a 0. 0, 0, 0, 1. That's a 1 in a decimal. 0, 0, 1, 0. That's a 2 in a decimal. 0, 0, 1, 1. 3 in a decimal. 0, 0, mistake. 0, 1, 0, 0 is 4. 0, 1, 0, 1 is 5. 0, 1, 1, 0 is 6. 0, 1, 1, 1 is 7. Now, as we write these down, be aware that if I keep moving the numbers consecutively, 0, 1, 2, 3, 4, 5, try to look at what the pattern is going to be on the binary side. We see that the least significant digit alternates 0 or 1, a 0 or 1, a 0 or 1, a 0 or 1. The next bit is going to alternate 2 zeros, 2 ones, 2 zeros, 2 ones. Then the next bit will be 4 zeros, 4 ones. Then the last bit will be 8 zeros, 8 ones. Okay, so let's just keep repeating. To repeat, I'm going to start a second column here. So we get 1, 0, 0, 0. Well, that's 8. 1, 0, 0, 1. 9. 1, 0, 1, 0. That's 10. Well, for hex, I'm going to put hex in red. I'll come back and put hex in a little bit. 0, 1, 1, 1 is 11. 1, 0. Oh, sorry. 1, 1, 0, 0 is 12. 1, 1, 0, 1, 13. 1, 1, 1, 0, 14, and 1, 1, 1, 1 is 15. Okay. In hex, I'm going to put the new hex numbers in red. 10 is our A. 11 is B. 12 is C. 13 is D. 14 is E. And then 15 will be our F. Now, if there was any items you would want to remember, remembering all the binary of 4 bits is probably the most convenient and most useful for you going forward. Because we're always going to try to break stuff into smaller segments. Kind of like how credit card numbers kind of make it a little bit easier. It's always 4 digits, 4 digits, 4 digits, 4 digits. A phone number, it's 3 digits for the area code, 3 digits, 4 digits. Kind of break numbers into chunks. It makes it a little bit easier to remember. All right, so let's take this long number and see what can it be in hexadecimal. So we're going to take that number and let's paste it. All right, we're going to break things into 4-bit chunks. So I'm going to take this items and I'm going to say, okay, 1, 2, 3, 4. That's one chunk. You always start at the right side. Another 4 bits, another 4 bits, 4 bits, 4 bits. Okay, so we have these groupings. And now what we're going to do is we're going to take one of these groups and we're going to go look at the table above. All right, so let's see what's 0, 1, 0, 0. Well, 0, 1, 0, 0 is 4. All right, so let me write down 4. And I know that's what that chunk is going to be. the next one of 1101. Well, 1101. Okay, we see that. That's 13, or the value of D. Then we do the next one, 1100. That's the one right above. That's 12, or C. 0000, all zeros is 0. 0100, that was our first one. That was 4. And then 1101, again, that's a repeat, and that's D. So I have this item as binary. And then I can say, what is that representation as hex? It's 0x. And then I'm just going to write down these numbers: 4D, C, 0, 4D. Now, this is going to be a little bit easier. Like we said, try to express it to another person. It's easier to say, okay, I want you to write down a number: 4D, C0, 4D. Very easy to represent. Once that person writes down that number, they can go and they can do the opposite. They can take the hex and convert it into binary. So let's do that now. Let's say I have a hex number and I want to change it into binary. All right, so let's say the hex number I have is C372A. All right, so to do this, what I'm going to do is I'm going to take C. I'm going to use blue here. It's made up of 4 bits. So let's go look at see what C is. C is 1100, 1100. So that's the first 4 bits. Then let me highlight 3 in green. Takes 4 bits to make up the 3. That's 1100. Then let's do 7 in purple. 1, 2, 3, 4. All right, so that is going to be 7, which is 0, 1, 1, 1. Then let's do 2 in red. All right, so 2 is 0, 1, 0, 0. And then let me underscore orange A. Well, A is 1, 0, 1, 0. So let's just go back and look at A. See, A is 1, 0, 1, 0. And that's how we can take a hexadecimal number and make it into binary. Like I said, if you're going to remember any binary numbers, you want to remember all the 16 possibilities for a 4-bit number, because that's something you're going to keep using multiple times. A lot of times, instead of just like when you're programming code and you want to see what's in memory, you can use like debuggers. And sometimes the debuggers are going to give you the hexadecimal. Well, then you can take hexadecimal and you convert it into the binary to see what bits you have. All right, so this gives you the idea of how we use hexadecimal numbers.